Hello, thanks for joining us today. I'm Cecilia Fisher, Marketing and Communications Lead for the School of Engineering and the Built Environment here at Edinburgh Napier University. I'm joined by Suha, the Programme Leader for Architectural Technology, and Mila, who's a lecturer in this area. We're going to chat about offsite construction, a key topic covered in modules on our architectural technology programmes across undergraduate, postgraduate and graduate apprenticeship courses. Suha and Mila will lead the conversation and I'll jump back in at the end with a short Q&A. Over to you, Suha.
Thank you, Cecilia. My name is Dr. Suha Jaradat. I am an associate professor at the School of Engineering and the Built Environment. I'm also a senior fellow of the Higher Education Academy and a chartered architectural technologist. I also lead the architectural technology programs at the School of Engineering and Built Environment, including the undergraduate, graduate apprenticeship, and master's programs.
That's fantastic, Suha. And I'm Dr. Mila Duncheva. I have a PhD in architecture from the University of Strathclyde in Glasgow, after which I worked at the Centre for Offsite Construction and Innovative Structures right here at Edinburgh Napier University. And now I'm a lecturer in architectural technology within the School of Engineering and the Built Environment.
Thank you, Mila. So yeah, today we're going to learn more about offsite construction. So maybe we can start, Mila, if you can tell us a little bit more about what is offsite construction and explain a little bit more about the process.
Yeah, of course. Thank you, Suha. This is a really great question. So offsite construction is all about transferring work from the building site to a controlled factory environment. And here we see some great examples from CCG OSM located in Glasgow, with whom we work very closely. So what you notice in this photograph is that we can see the manufacturing line, a linear manufacturing process in which materials are stacked according to the location in which they're needed. We also see different levels of automation for some of these screens and equipment. And just to mention some of the materials which we're looking at are part of ongoing research projects such as Offsite Ready, funded by the Construction Industry Training Board. Now, offsite construction has many different typologies. We can see the four main ones here. I'm going to start with sub-assemblies and components. Here we see a truss designed in collaboration with Maca Construction. Now, this component is manufactured and then delivered directly to the building site. It doesn't have any insulation or sheeting or any windows, etc., because it's truss, it doesn't need them. But sub-assemblies can also be precast staircases that are used in apartment blocks or other components. In the manufacturing process, the sub-assemblies will be moved forward in the factory if they're not taken directly to the site to produce panelized systems. These are planar two-dimensional wall or floor segments, which can be either open or closed. When I say open, we see this example here by Stewart Mill Timber Systems, in which we have the structural timber frame and then sheeting on one side, but the materials such as windows and insulation are added on the construction site directly, or indeed more advanced systems with more work completed in the factory can be volumetric systems. Here we see an example by Carbon Dynamic, located near Inverness, with whom we work as well. And this is a three-dimensional unit, by which I mean like a box which has several rooms and very high levels of finishes, everything from the built-in furniture to the light bulbs, the mechanical, electrical, plumbing systems, etc. are fitted in the factory. And of course, in hybrids, we can see an example from a work with David Blakey Architects. We can combine different types of these systems to find the most suitable solution for a project. Now, just to give you a bit of a flavor for the manufacturing process, here we have an example of a nailing bridge, where you see this is a semi-automated piece of equipment where a file tells the equipment where to put the nails, which then connect the sheeting or the oriented strand boards onto the timber frame in a matter of seconds and within the exact tolerances required. When we get to the building site, then the components are transferred usually from the back of a lorry or a truck into the final location. And here we see an example from a affordable housing site in Scotland. This unit with windows, with doors pre-fitted, is about to be fitted on the saw plate, on the foundations, with the electrical and water mains connected directly to the unit, which makes it habitable afterwards in a matter of hours. And of course, the finished product is an important part of that process, Suha. Here we see a fantastic example from Denmark, the Red Corner Kindergarten or Nursery, which shows really some of the creativity that's possible with volumetric or modular construction. Every part of this project was delivered using volumetric systems, including the playground, which has lots of different angles, etc. And through mass customization or variety using standardized components, they achieved a very interesting facade with very different windows to enhance that creativity element.
Thank you very much, Mila, for this interesting overview of offsite construction. Can you tell us a little bit more about why offsite construction and how is this linked to sustainable development? It would be helpful if you can elaborate on some of the benefits as well as the challenges or limitations of these new methods of construction, modern methods of construction.
Yeah, of course. Thank you very much. That is another fantastic question. In terms of why offsite, there's no one direct answer. The answer is really complicated, and that's part of why myself and Professor Robert Hastings wrote a book chapter in a book which you can see referenced on the screen. So there's 6 main reasons why one would build using offsite construction, and indeed the leading one is sustainability. So we talked about a little bit about mass customization. So offsite can also be embedded in the circular economy through items such as design for manufacturing and assembly, which we saw, but then you can add plus disassembly. So that's where you think not only about, okay, how will this building be manufactured and constructed, but also how can it be taken apart so that the components can be reused, refurbished, and then reused in the built environment as well, really to reduce that wastage of demolishing buildings and starting anew. And of course, there's other social, environmental, and economic benefits, which I'll talk about later. But we do experience some challenges as well, especially in terms of culture. People in the built environment tend to be pretty set in their ways. It's difficult to bring a new process, even if just because from a contractual point of view, innovation equals risk in many cases. It's not all bad in terms of culture. We offsite construction, because we have more standardized processes, we are seeing more females employed in the manufacturing and in the construction of these buildings, which add to the diversification of the sector. And of course, when we start to talk about diversification and manufacturing process, we start to allude to human capital or skills, which we see in the purple there. And in construction, we have a big shortage of skills, with apprenticeships reducing over the years. And with offsite, what we can do is mitigate those skills through really targeted training and upskilling in the factory, as well as enhanced collaboration. We have here in Scotland, supported by Edinburgh Napier University, Offsite Solutions Scotland, which is an innovative cooperative of 10 offsite manufacturers coming together to collaborate and innovate offsite construction in the built environment. And of course, there are other aspects such as productivity. which is something that I'm particularly interested in. So we have something called lean thinking, which some people may be interested in, where you create efficiencies in the process through just-in-time manufacturing, for example. So you remove any sort of time wastes. And we have lots more opportunities through digitization, which is really fascinating with building information modeling and the Internet of Things in Industry 4.0. Something we're working on at the moment as part of this are digital twins, which which are essentially a virtual copy of the built asset of the completed building, and can have live data such as carbon capture or energy use to see how your building is performing in real time. That's really exciting. It's sometimes all of this is really driven by regulations. Now, again, regulations is one of those things that can be both an advantage and a challenge. So here in Scotland, again, very strongly, we have the Section 7 volunteer regulation, where people can achieve higher than the minimum sustainability requirements with the silver and the gold, as well as the active version of those where you add renewable energy. And very often the want of the developer to achieve that higher sustainability regulation leads them to offsite construction. But of course, there's also challenges such as the need to certify products or the need to comply new products to old regulations. So that can be a challenge as well. And talking, a bit more specifically about the manufacturing process, instead of offsite construction in general, we do see sustainability is a key point in this, especially social, environmental, and economic. In all these aspects, you see sustainability, value, and efficiency are interconnected. So let's take, for example, quality. We saw the nailing bridge and the manufacturing process line at the different companies. Now, because before a component moves from one stage to the next, it's always inspected for quality. Because you use more semi-automated equipment, which doesn't make mistakes, it's very precise, we have that increased quality control in the factory environment. That then leads to installation, for example, not getting wet or not getting damaged, always being properly installed in the buildings. And installation is one of the key elements which helps to making a built environment more energy efficient through reduction of elements such as code bridging, etc. If you're not familiar with all these terms, don't be afraid. You get to know them when you come to study with us. And I'll just touch on something else as well as waste materials. Again, in the factory environment, because you can use semi-automated equipment, including optimizing source, waste materials are typically very, very low. As much of the waste, as much as the materials, are used as possible, and often only about 2 to 3% of the waste is sent to landfill. Everything else is recycled, which is very beneficial. And of course, that adds not only environmental sustainability benefits. Otherwise, construction is one of the #1 contributors to waste materials, but it also adds a bit of that economic sustainability as well, because it means you're using your materials resources more efficiently.
Thank you so much. This is very informative. Can you elaborate on how does this inform learning and teaching in the architectural technology undergraduate and postgraduate programs? And how is this linked to research activities in the School of Engineering and the Built Environment?
Yes, Zuha, thank you very much. So in terms of learning and teaching and research, I always think of them as two integrated aspects, just like you suggested. So at Napier, not only the Center for Offsite Construction and Innovative Structures, but also other centers that deal with smart technologies, do a lot of research working with leading practices and public bodies in Scotland, internationally, and in the UK. And this is embedded in our learning and teaching activities. So, for example, here we see Eco Retreat at Falkland Estates, which is courtesy of Dr. Andrew Livingston, one of my colleagues, who worked on the building information modeling of these small off-grid dwellings and their analysis in terms of carbon footprint and how that can be reduced by using as much timber as possible. Now, this links directly and indeed is typically one of the case studies in the analysis of Architectural Technology 1, a first year module in which students design an eco-retreat based on a client's brief, and they also give a final presentation and submit a portfolio. Now, this is a really great module to start off with in first year, because students get to firstly develop a real project from start, from analyzing the client's requirements all the way through conceptual design, through technical design, and producing the final outputs in terms of technical drawings and renders. But they also get to develop key business skills which are sought after in industries such as presentations and teamwork and being proactive as a team member. So that's just the start of the learning and technology journey, learning journey in architectural technology. We've also got an example from the Design for Manufacture second year graduate apprenticeship, in which students get the opportunity to analyze key case studies, but also then think about through established research methods, how do the benefits and challenges of offsite construction relate directly to their practice? Because these are students who have a background in practice. So here we have some examples provided by the Offsite Awards, and this was linked to the Offsite Ready learning research project, in which we were the lead in creating a range of learning and teaching materials and CPD materials that can be used across the UK, including some videos and some animations which can be embedded directly into learning and teaching. So as we see here, some very inspiring projects, also going in depth into the technicality, such as the assembly on site. And it doesn't stop in second year, it continues all the way through with some examples such as Timber Architectural Design and Technology, which is a master's module, but also Building Design and Technology 3 in third year of the Architectural Technology program. So here we see, again, an image courtesy of Dr. Andrew Livingston and Victor Henkel. This is that same recreational hut we saw, but its analysis as well as technical drawings produced directly from the building information model. So you can see the cutting list, for example, of timber components, how many they are, and adding that social sustainability element from a research project funded by Scottish Forestry, is how can this be manufactured so that two people can install it in the spare time. Two people can lift it and install it safely. So that meant that the panels had to be less than 50 kilograms in weight. And it's very interesting to program the model to achieve that weight classification of each panel. And again, that's research embedded directly into teaching, because afterwards students get to learn how can they, what are the timber properties such as durability, how can timber be graded, and how can technical drawings and specifications be produced as well.
Thank you very much. This is very interesting to highlight our research-informed teaching within the school. And this is, of course, only one part of what we do at the School of Engineering and the Built Environment, and what we teach in the architectural technology programs, which are much broader and wider than offsite construction only. We are involved in a wide range of research activities, including building information modeling, historic building information modeling, and which is about the digitization of the built environment, using various software applications designed to improve environmental sustainability and development, There is a lot of research on smart cities, on energy, building performance, refurbishment, circular economy, and much, much more. Actually, we are at Edinburgh Napier University, the architectural technology programs in particular. We are accredited by the Chartered Institute of Architectural Technologists, the CIAT. Our programs are also accredited by the CIOB, the Chartered Institute of Building. At Edinburgh Napier, we also hold one of 4 CIOT Center of Excellence status. We're one of 4 institutions that hold this status, which requires the educational institution to have a robust culture of research that has a significant and direct impact on architectural technology. We were awarded this CIAT Center of Excellence status since 2013 because of our active engagement with research and our teaching at postgraduate levels as well. So if you are interested, there is much more information about our courses, about our publications and research activities. You can check the website, and please do get in touch if you have any questions. Hopefully we will see you joining us soon. Thank you. And now we can have questions.
Thank you, Suha and Mila. That was brilliant. A great presentation and a wonderful insight into offsite construction, and a good rounded finish there with a quick intro to all the courses. So I've got a few questions. So my first one is, what makes offsite construction more sustainable?
Yeah, I can answer that question, Cecilia. I think that's a really interesting question, which has, very, very many broad answers. I think what makes offsite construction sustainable, for me, in my opinion, is really that controlled factory environment, which brings social, environmental, and economic sustainability benefits. So let's look at each of them. So in terms of social sustainability, people who work there are protected from the weather, protected from the elements, and also they have one single place of work. So that means that they know every day how long the commute is going to be, etc. And that helps them have a more controlled lifestyle or work-life balance as well. Because with offsite construction, some of the work is moved to the factory. That means that there are less deliveries to the building site, because some of the deliveries going to the factory instead in terms of materials. So the reduced deliveries near the building site actually impact on the local community as well, because you have less disruption, as well as less noisy equipment from the reduced time on site as well. So that's the social sustainability. In terms of environmental, we do have that increased or at least guaranteed quality. The quality is controlled, which means that if a building is specified to have a certain U value or a certain energy performance, it will be as close as possible to that design specification, because one of the challenges we see in the industry at the moment is the gap between as designed and as built. And offsite doesn't offer a miraculous solution to this, but it does help us get closer to the as designed environmental performance. And in terms of economic, I touched briefly on the time on site. Now, time on site is associated with costs such as the project manager, the construction manager, but also loans need to continue to be paid while the building is under construction. And indeed, if it's a building that brings income, increased time on site means you can't start bringing in that income. With offsite construction, the foundations or the groundwork and the offsite manufactured activities can take place at the same time, and ultimately that can result in a shorter construction program, which means that revenues from the building can start coming in sooner. Or if it is an educational building such as the nursery we saw, it means that the building can definitely open in time for the start of term where all the pupils start coming in.
Thank you for that. I can definitely see the value in the process. So that leads me nicely into my next question. Should all construction companies adapt to this process, the offsite construction process?
I can answer this one. My answer is no. This is, despite all the benefits and the value in using this, it's not for everyone. And this will also depend on the type of the project, on the brief, on the location of the project, on the client requirements, on the materials used, on many, many, and much, much more different variables that will define if this is possible or not. Yes, so yeah, for certain projects, it can be very helpful and very efficient way of doing construction. For other projects, maybe traditional methods of construction will be more suitable. So yeah, it's not for all the projects and not for everyone.
Thanks for that. And how common is offsite construction in the UK when compared to the rest of the world?
Yeah, that's a really interesting question, Sila, and I'll ask that if you don't mind. So we actually completed recently a collaborative research project called Increasing Offsite Construction in Scotland, which was with other colleagues such as Mark Deacon, Alistair Reid, Luca Mora, Robert Hairstans, and the Glasgow School of Art. It was for Scottish Government and Scottish Enterprise and the Construction Scotland Innovation Centre, and that was part of that was to analyse the size and the capacity and the productivity of the offsite construction sector in Scotland right now, compare it to the past 5 years, and have an outlook into the next 5 years as well. Now, what we found is that offsite is prevalent. In Scotland, around 80% of new dwellings are completed using some sort of offsite construction technique. It's mainly panelized systems with a small percentage of volumetric systems as well. In the future, what companies projected was that the panelized systems will become more advanced, so they could start adding more insulation, more windows, more components in the factory for the panelized systems, as well as a marginal increase in the volumetric or the more finished three-dimensional systems we saw as well. Now, how does that compare internationally? Now, if we compare it very close to the border with England, for example, there the percentages for offsite are much smaller. I'm not sure what the exact numbers are, but they're probably around 10 to 20%, but that creates a really good opportunity for offsite manufacturers from Scotland to export products to England. So there's an opportunity for market increase there potentially. But how do we compare as a whole the United Kingdom to other countries? Well, if we look at let's say the United States, right across the pond from us, that the Modular Building Institute, some of our partners there, including Ryan E. Smith and Ivan Rupnik, have been working on a project that targets 5% of output for what they refer to modular, we call it offsite construction. So in terms of comparison to other economies, we're actually quite advanced, and our collaborative nature is very often mentioned in reports internationally in terms of how well we collaborate to increase the sector as a whole.
Wow, it's really interesting. It looks like we're ahead of the game there. So what is the future trend of offsite construction?
Yes, I can see this is related also to building information modeling, and this is where the industry is going, trying to increase the digitization of the built environment using various software applications to address issues of carbon value and cost, save time, and increase the quality of the project. So this is closely related to that. So that's where the industry is going, to increase efficiency, save time, and save money. So I can see this closely related with building information modeling and where the industry is going these days. Maybe, Mila, you can also add on to this about the use of a wide range of tools and digital technologies, and how is this implemented in our school, in our programs?
Yeah, of course. So my colleague, Dr. Andrew Livingston, and Robert Hairstans have worked continuously over the years with Trimble, and that has resulted recently in a gift agreement by Trimble, resulting at the first ever Trimble Technology Lab in Scotland being established right here at Edinburgh Napier University. Now, what does the Trimble Technology Lab mean for students? It means that you get to access software as well as hardware as part of your studies. That includes pro licenses for a lot of advanced software, some of whose outputs we saw in the slides. And that's for architectural technology, as well as for more structural calculations, as well as project management, analyzing construction progress, etc., and collaborative working BIM workflows, which is something we're working with a group of students right now. Actually, we're using Trimble Connect for design projects to enhance really that experience of the student design project mirroring or even being more advanced than what is done in practice in terms of building information modeling. And in terms of hardware, we do have some pretty exciting hardware, such as a HoloLens, a smart hard hat, which you can use with augmented reality on site to either check against the as designed element or to investigate different aspects on site. So that's really next level for me. It's almost sci-fi technology. And of course, we've also got a drone, which has, I believe, infrared filming capabilities as well, which is quite interesting, and other things such as very advanced photo stations. So students get to benefit from a lot of both hardware and software from the Trimble Technology Lab.
Yes, and I have also been heavily involved in the design and the refurbishment of our design studio and the Trimble labs. So we are updating our facilities to accommodate the use of these different software and hardware technologies that we have.
That's great, thank you. I remember the launch of the Trimble Lab, so there was definitely a few really cool equipment there to try out when I was there. So it's great that students have access to this. So my final question is around an example project specifically focused in offsite construction. Can you give me an example in any of the undergrad, postgrad, or perhaps graduate apprenticeship routes as well?
Yes, so for example, the students in their dissertation modules, particularly for the graduate apprenticeship undergraduate program, they can, if they are interested, they can choose offsite construction as a topic of their dissertation. However, yeah, there are also a wide range of research innovation, different topics that they can choose, recent research topics that they can choose in the master's program as well. They can also choose this as one of their dissertation projects.
Yeah, that's great. And just to jump in there, Suha, if anyone is thinking of offsite construction and a master's and is interested in offsite construction, or indeed in any other work with an industry partner through the Built Environment Exchange at Napier University, which t-shirts I'm wearing now, and the Construction Scotland Innovation Centre, what we can offer to prospective students are scholarships for MSCs. So be on the lookout. We will be announcing those soon. What that means is that you can get a fully funded MSc to advance your knowledge in the built environment.
That's great. Thank you very much. And that brings us to a close and for this presentation and our questions as well. So thank you, Suha and Mila, for your time today. And if anyone has any questions, you can find all information on the 3 architectural technology courses on our website, and you can get in touch, and I'm sure Suha or Mila will be able to answer your questions further as well. Thank you.
Thank you.
Thank you very much, both. Thank you, everyone.